And now in 20 minutes you're going to have a dialogue with the scientists here at the Nils Bohr Institute.
Mm-hmm.
It's been some decades since your ideas have been presented here, hasn't it?
Yes. Well, I came here in 1957 for 1 month in the summer, and then again in 58. Now, at that time I was just moving from Israel to England, and we spent a month here at the Institute. And, we talked about physics mostly at that time.
Do you find that the kind of ideas that you present are easily understood in an environment like the Bohr Institute?
Well, I haven't tried the Bohr Institute. I just came, but I think that scientists find it harder in some ways than many other people, you see, than some other people, because there's still a strong commitment, even perhaps partly unconscious, to the old atomistic worldview.
So what you're saying is that science has shown us something that scientists do not want to see.
Well, they have become so used to the way of seeing it that they don't want to change it. You see, they feel uncomfortable about changing it, and they feel there's no reason to change it. Many of them, they say, well, we're doing so well now, why should we change it? In one sense, it looks as if we're doing very well, you see, but if you look at the broader view, it looks very dangerous.
Now, many people are talking about this new worldview that's coming up these years. Do you see a new worldview coming up in the Western world?
Well, in a certain part of the Western world, yes. I think a worldview in which there's more focus on wholeness, on process, rather than on analysis into parts and more static constituents.
But does that come up because we want it, or because we are forced to take on it?
Well, probably both. I mean, that is, I think a certain fraction of the people want it. Perhaps they're tired of the old one, they don't feel it's working. And also there is some evidence for it, I think, especially in physics, and probably in other sciences as well. The evidence in physics comes partly from relativity and partly from quantum theory, or perhaps more from quantum theory than relativity.
And what kind of evidence is that?
Well, in relativity, we have a notion of a universal field, which is dynamic, flowing, and according to Einstein, particles should eventually emerge out of this as singularities or very strong regions of stable pulses of field, which gradually merge, the fields gradually merge with other particles. So we have an unbroken universe which is in constant flow dynamically. And even the very notions of space and time have become relative, so which were previously absolute. And they may even go on to singularities like the black hole or the supposed beginning of the universe, where the present laws would break down altogether, all concepts that we know. So that's a very revolutionary view compared with what we had, say, a century ago. And then there's quantum theory, which perhaps is more revolutionary. And it's hard to explain that in a short time, but there are three main features, I'd say. One is the notion that a quantum process is in some sense indivisible, that it is one whole which it can be broken, but then it becomes an entirely different process, so each process is a whole. Otherwise it can't be what it is. And all the quantum processes of movement are linked, as it were, into one whole. Now, the second point is the wave-particle duality, the discovery that, say, electrons, which are normally and classically particles, can behave statistically like waves in a more precise experiment. And light, which is classically a wave, can behave like a particle in a more precise experiment. So it seems we have these two aspects which depend on how the system is treated, context-dependent, which is quite different from the classical idea that whether it's a wave or a particle is intrinsic. Now, the third point is what's called non-locality, that we find that in certain conditions there's apparently an immediate connection of distant particles. It's rather hard to explain. We can't use it for signals, but still it seems to be there. It's connected with the experiment of Einstein, Podolsky, Rosen, and has been checked by, has been tested by Bell's theorem and Aspect's experiment. It seems pretty well established, right, both theoretically and experimentally. Now, again, all of these you see combine to the notion that the universe is a kind of indivisible whole, rather than analyzed into constituent elements which interact as separately existent.
But how much can you tell about this indivisible whole?
Well, we can tell quite a bit in the sense that all the laws of quantum mechanics are concerned with it, you see. I mean, you can tell, well, I don't know what you want to know, but I mean, all the laws, you compute the properties of all sorts of things. Like, for example, take superconductivity. At high temperatures, the electrons will generally scatter off obstacles in metals, and therefore there will be a resistance. You see, the current flow would stop unless it's maintained by a voltage. Right? At very low temperatures in certain metals, the current flows indefinitely without scattering. Now, this is a quantum effect, you see. Now, as far as if you analyze it, you can see that it's due to the fact that the electrons are sort of held together in some way by these non-local interactions, so that if there's an obstacle, they go around and reform rather than scatter. It's rather like a ballet dance, the people going around and reforming, whereas in a crowd, each person is following his own purpose, and they all scatter. They all get in each other's way.
So this unity also creates a kind of ordering of things.
Yes, it can create a kind of ordering of things, but at the same time it explains, you see, you can see that there are situations where we have this high degree of order and others where we don't. That it's possible within the mathematics to see that when something called a wave function can be represented as a set of product of independent factors, and all the particles behave independently. But in a more general situation, they don't. So you can explain why we have so much independence in ordinary experience, and yet why, in a more careful probing, we find order, new kinds of order. So the classical level, Newtonian level, is explained by quantum mechanics as a limiting case, you see, of a more, so that you have a whole, but the whole determines itself to behave somewhat like independent parts in many cases. So even whether it's going to be behaving like parts is determined by the whole, right?
But what we can see is the parts rather than the whole.
Well, we see, in physics, we see the parts because that's the way we approached them in the last few centuries. I don't know if, you see, I think our perception is influenced by our way of thinking, so that we accept this mechanical way of looking at things. But if you went back 1,000 or 2,000 years, I don't think people actually saw the parts as primary. The way we see it depends on the way we think, you see.
But is it a choice? Do we have to choose between the whole and the parts?
No, well, you see, it's a question of whether you have a holistic approach which puts the whole as primary. See, in classical physics, the parts are the primary concept, and the whole is only an auxiliary concept, which is convenient for when you have many parts working together like a machine. But the parts are taken as the basic reality, right? And saying just subjectively, we find it convenient to think about the whole. But in quantum mechanics, I think there's something else, that the whole is objective, and the parts are the result of analysis. But we have large areas where the whole behaves to some extent like independent parts, right?
So you're saying it's really us that make up the parts?
Well, we actually make up everything in the sense all these theories are made up by us, but in these theories we place the parts, we may either place the parts as fundamental or the whole as fundamental. Right? Now, the quantum mechanics is placing the whole as fundamental. That's, I think, the most basic change it makes, right? Finally, every theory is made up by us, and we are going to see whether we can apply it coherently to reality. You see that I think we could make an infinity of different kinds of theories, and some of them would be more coherent than others, you see. For example, if somebody is said to be mentally disturbed, he has another theory which we think is incoherent, but to him it looks coherent, right? because we can always ignore what is not working, you see. Or we say we'll solve that later.
You just said that in reality we make it all up, not just the parts, but also the wholes. Could you explain?
Well, I think that's the question. What is the relationship of theory to reality, you see? Now, one view is that it reflects reality, you see. Now, I think that it corresponds to reality. I think that view is only limited, right? Like a map is said to correspond to a city, but there's nothing on the map that corresponds to anything in the city. In the map you see dots of print, and the city, which is very vaguely defined, the city is also vaguely defined. So what corresponds is certain abstractions that we abstract. Right? But the map, the real test of the map is that it guides us correctly in the city. And if it's a wrong map, we will find incoherence in our action, right? Now,
but it's not that you can compare this bit of the map with this bit of the
well,
city.
only in a rough sense, but that's an abstraction. You can compare it, but it's abstract. Right? Now, you see, so therefore we make it all up, but the question is how coherent is it when we try to make it work? You see, that's really the key. Some theories are more coherent than others, but it's often hard to tell because when we come to a theory as broad as a worldview, we find it very hard to detect incoherence because the worldview tends to state that things that don't fit are irrelevant, or else says we're going to get them in order later. We haven't solved that problem yet. So incoherence can easily be not noticed, right? But if people are and also people would like not to have their worldviews questioned because they have got used to them and feel comfortable with them. So therefore it's very hard to question a worldview.
But in effect that's what you are doing.
Yeah.
And in effect you are questioning the whole Western worldview.
Yes, well, yes, I think even all the worldviews need to be questioned, the Eastern and the Western. See, the West has, in a sense, implicitly questioned the Eastern worldview. Every worldview, I think, is limited. But I think the Western worldview, its limits have not been seen. And we need to go to a broader view, not necessarily back to the Eastern, though it may include some of the Eastern. But I think we need a kind of dialogue of these worldviews to go to something beyond, right?
Where do you see the limits of the Western worldview?
Well, just in the way of saying that it focuses too much on analysis and it tends to lead to fragmentation. You see, now what I mean by fragmentation is not just division, distinction, but because the parts in the whole are correlative concepts. You see, a part is a part only because it's part of a whole, like a machine or a watch, right? Now, a fragment is something it means break it up, you see. That's the root of the word, to smash, right? So if you smashed a watch, you would get fragments. Now, the Western view, it aims at getting the true parts of the universe, but in some ways, perhaps it gets fragments, not to some extent in physics, but much more so in fields like biology, psychology, sociology, and so on. Right? Now, if you break it up falsely into fragments, then you have confused. You see, you're going to treat these as separate when they're not, and also you're going to unite what's in the fragment when it's not united, right? So it leads to confusion.
So in the West, you tend to confuse the part for the whole and vice versa?
Yeah, you get confused about the part and the whole because you take a fragment as an independent whole.
But if you take the true whole that includes everything, it would also include you and include your perception of the whole.
Yes.
So could you ever tell me your way of perceiving the whole to anyone else?
Well, we can have a dialogue and so begin to exchange, you see. In other words, I can't tell you unless we're talking together. You see, we have to exchange our views on that, right? And perhaps now, and then there comes the problem if people are ready to listen to somebody else's worldview, you see, seriously, without resistance, without opposition. But I think the observer is an intrinsic part of the whole. That's what quantum mechanics is teaching us too in physics, right? That the observing instrument is just as much part of the whole, and therefore, because of the possibility of these non-local interactions in quantum mechanics, when an observation is made, the two systems are not really distinct, you see. Therefore, they participate in each other, and you cannot therefore get an unambiguous meaning to the measurement, right? The same happens between human beings. You see that if somebody tries to measure somebody else, talk to him, there's a mutual change which makes it impossible to get an unambiguous attribution of qualities.
It's not possible to say what David Bohm would have said in another interview.
No.
Tomorrow at the same time.
No, because we're participating together, so what I am is affected by what you're doing and what you are, and vice versa, right? That's exactly the sort of thing that happens in quantum mechanical observations.
Okay, if I say then that when I think about the whole and the part, I end up understanding that if you understand the whole, you're not able to tell it to anyone else because then you step out of the whole and become a part.
Well, I think there's a kind of communication. See, this is the point about having a different worldview. There is a kind of communication that does not begin by denying wholeness, you see. You see, if we say, here am I and here are you, and then we have already divided it, right? But perhaps we could communicate in the spirit of the whole without assuming that division, right? See, we're not trying to tell, that means I'm not trying to tell you what I think, you not trying to tell me, but rather together we are trying to discover how we're going to think together. Do you see the difference?
Indeed. Is that possible in ordinary language?
Yes, I think it is. It depends on the attitude rather than the language. Our language has been developed so as to emphasize the part, but we can still use it differently, I say. For example, poetry uses language differently, and it is always possible to use language in new ways.
So the basic obstacle is more the attitude of the people involved than the theoretical or verbal.
Yes, we could improve the language. Maybe it would someday it will improve in that regard, but we can proceed without that.
Now, this attitude problem of discussing the wholeness would then couple to the question of whether the new worldview is something that you are forced to take on or something that you wish to take on.
Well, I don't think you're forced ever to take on a worldview. Finally, in fact, you see, if you take the medieval worldview, it would probably seem perfectly satisfying to those people. Whatever wasn't fitting, they said, well, we don't quite understand it, or God, well, that's mystery of God, or whatever, you see. There are things in our worldview we don't understand. The favorite answer is to say science will explain it later, you see. Now, you can't be forced to have a worldview. You can merely say that the evidence is such that you are convinced, you see, and and that it seems coherent to you.
But the psychological attitude towards a new worldview could either be one of that you feel happy that you're liberated, or that you feel that your old worldview crumbles.
Yes, you may want to cling on to your old worldview, or you may feel happy that you're free of it, you see. And I think that people are becoming less satisfied with the old worldview today, generally speaking, that they're not satisfied with this fragmentary view because it has led to so many problems, so much incoherence in the human relationships in society, and with the ecology and so on. You see, that, for example, this fragmentary view has led to treating the whole Earth as a bit fragments to be exploited. Now, that all adds up in the whole to this destruction going on, you see. So as long as we think that way, it will probably go on, you see. People may take a fragmentary approach to repairing the ecology, but it won't work, right? Because that is a situation where the analysis into parts is not relevant, you see. They're not sufficiently independent to allow for such analysis.
So really what you've seen in the physics of the atom is 50 years before the general societal condition called the ecology crisis. You've seen the breakdown of the description of parts.
Yes, probably. Yes, it began to be clear about 1930 or so. You see, with Einstein, Rosen, Podolsky, it was already implicit, right?
That's 35.
35, but people had a feeling for it perhaps before, you know, I mean, without expressing it.
So but why could physicists see this breakdown of the description in parts 50 years before general society?
Well, they were working on a rather restricted area where the evidence was such as to bring it out. You see, because the area was limited, it was possible to focus more on the problem, right? Whereas the whole social problem is far more complex, and it's so complex that people could always say, you know, maybe it's not that way.
But isn't it still surprising that you are able to go from physics into more general problems?
Not to me, you see, because I think that that's a sign of the wholeness. You see that. There was a medieval view, which I think, there was much more wholeness then. There was a medieval view that everything was an analogy to everything. You see, a human being was a microcosm of the cosmos, so that he had implicit in him the possibility of understanding it. Right? And then you see that the general view before our modern times was more favorable to wholeness, right? Even in Europe as well as in the East, right?
Niels Bohr's interpretation of quantum mechanics, which is the mainstream interpretation, it differs from yours.
Yeah. Yes, well, I wouldn't, I would say in some sense it's the mainstream, but I think not a great many physicists really understand it very well, because it's very subtle. Originally I was very much in favor of the Bohr interpretation, which seemed at that time the best, and it's very subtle and hard to explain, but basically it emphasizes this wholeness of the observing instrument and what is observed, that they are one whole and they are one phenomenon. And now the thing and many of the things which he says would be on the lines which I have just talked about, right? That's why it attracted me. Now I won't go into more detail about it because it's very difficult, but the one thing I feel I didn't quite agree with was that he said that this whole was completely, there was no way of making a concept of this whole, you see. Right? And that meant that you could not make it intelligible. The mathematics would only refer to the probable results of experiments, would not discuss what is actually happening, right? Now, so I developed later in 1951 or thereabouts another interpretation where I said that the electron is a particle, for example, and then it has a field, what I'll call a quantum field, represented mathematically by its wave function. And this field and the particle are together, and they account for the properties, the quantum properties of the electron. It's a new kind of field, right? Now, we know classically we have many fields, like the electric and magnetic field. The magnetic field, for example, you see iron filings showing how it spreads through space. The electric field, the electromagnetic field makes radio waves radiating through space. But the quantum field is different. It has some similarities, but it's different because the effect of the quantum field depends only on the form and not on the intensity, you see. If you think of a water wave, it's spreading out. If the cork is bobbing, the more it spreads out, the less the cork bobs. Now, the quantum field would be capable sometimes of spreading out, and the electron far away could move with the same energy as if it were close. This would be a kind of explanation of this discrete quantum process.
So you have a field that doesn't drop off when you go towards...
The field drops off, but its effect does not, you see. The effect depends only on the form, right? Not on the intensity.
That's weird.
It's not so weird. In fact, it's very common, but we generally don't pay attention to it, you see. You see, if you take, for example, a radio wave, its effect falls off. Now imagine a ship guided by radar on an automatic pilot. The guidance does not depend on the intensity of the wave. It depends only on the form, which we may say carries information. The word information has the two words in form, to put form in, right?
So it's like if you have a television set and you go far away from the antenna or the place where they put out the broadcast.
Yeah.
It doesn't mean that you don't get the broadcast. You just need a bigger receiver.
Sensitive receiver, that's all, you see. So as long as it's received, it's essentially the same program, you see. So what happens is that the form of the radio wave puts form into the currents flowing in the receiver, right? The energy comes from the receiver, not from the radio wave, right? The radio wave is not pushing the ship around mechanically. the ship is moving under its own energy, you see, and responding with the form. So the radio wave is guided, it's is giving shape and form to its motion, you see. So this goes back to an old idea of Aristotle, saying that there can be a formative cause as well, right? Now this is very common. We have it not only in radio. The computer has a form which is carried out in the process of, it may run machinery. You can have DNA. The form of the DNA determines, is carried to the RNA and determines the making of proteins, and so on. And in all human experience, you see, people generally don't push each other, pulling each other around, except when they're violent. They depend on the form of the sound waves to communicate, and the people move around because of that, you see. So the point is that this is the most common form of experience, and the mechanical business of pushing and pulling is more limited, but our experience of the past few centuries has led us to focus on that as the main point, right? And saying we can always explain the other thing through that. But I'm saying maybe it's that this form is fundamental, and that the electron responds with this form, you see. Now, that explains not only, it explains the interference, it explains why the electron acts like a wave, and it explains this non-local business, and so on, and explains the superconductivity as the electrons moving by a common pool of information, just as the ballet dancers do, and so on. So so that means we have quite a different principle of explanation, because this wave function, which operates through form, is closer to life and mind, you see. The basic quality of mind is that it responds to form and not to substance, right? And therefore, the electron has a mind-like quality, though it may not be, almost certainly not conscious in the sense we know, but consciousness may depend on much higher organization of this mind-like quality. So we could say it may have many new mind-like fields could arise, which we don't know, you see, in the human being or in life or animals.
So what you're saying is that the physical universe is really more about information than about substance?
Well, I'm saying it's both, but information contributes fundamentally to the qualities of substance.
If you said things like this to Nils Bohr, how would he have responded?
I don't know. He might accept it, he might not. You see, we did have some talks when I was here at the Institute, but I didn't have these ideas. I didn't have this idea about information then.
But if we try to compare the way that you see quantum mechanics with your field that has an effect that doesn't go off with distance, with the interpretation of Nils Bohr.
Well, Niels Bohr would say that there's no way to discuss this at all, that there's nothing but a phenomenon which is a whole, and even including the two distant particles. We can only discuss the mathematics as giving the probability that certain results will be obtained, right? Now, I'm trying to say this gives an intelligible explanation, you see. Now, it requires you to accept new principles, and you would have to say that this wave field will perhaps have a more subtle substantial basis, which we don't know, that would carry it.
But basically what you are doing is that you are interpreting quantum physics, the physics of atoms, in another way than the mainstream.
Yes.
And then and there are certain technical points where people like Nils Bohr would disagree, because he would feel that you enter discussions that human beings really cannot enter. I'm
not sure why. You see, his whole Nils Bohr's discussion is extremely subtle, and it's very hard to exactly pin him down. I think he would say that there's no point to this sort of speculation. He would regard it as a kind of speculation, or which was not tied to an experimental fact, perhaps. I don't know, you see. But I feel that it's important to be able to make it intelligible, and also to show the connection between this and the whole range of experience and other fields.
But there's, in effect, there's no difference at all between your view and the classical view of quantum mechanics, the Nils Bohr view of quantum mechanics, in its experimental predictions.
No, they'll give the same experimental predictions, but see, I think experimental predictions is only one of the functions of a theory. that it's a theory. It's enable you to understand what's going on, to make it intelligible, right?
But then when the general audience is presented with your views of the universe, it's often based on your interpretation of quantum mechanics. Do you think the general audience acknowledges that this is a very sort of minority kind of interpretation?
Right, I don't know. It's hard for me to know, you see, but you see, I think that the other interpretation, the reason it's not generally known is that it's not intelligible to them. You see, it's so abstract and difficult that they really can't understand what it says. Right? See, I think this interpretation will make the whole thing more accessible to more people, and also perhaps show the connection of different fields in some sense.
But in a way, what people from the Nils Bohr or Copenhagen interpretation school would say is that you're reviving a classical worldview.
It's not. I say it's not classical. You see, I say, for example, with this idea of active information is quite foreign to classical physics. You see, I say that the thing that makes classical physics is not just the form of Newton's law, but what you say about the forces. If you say that they are this character of information, it changes it. You see that I say that I'm going to introduce an entirely non-classical concept, which is the activity of information. You see that it contributes fundamentally to the properties of substance. Now, the fact that you still think of a particle doesn't say that it's classical. You see.
But in some senses, your view is more classical than the Bohr view.
It's more like the classical, yes. I wouldn't call it it looks more like the classical, but it's also quite different.
So could you say that it's the classical worldview, but with information
added? Some other things added as well, but which I haven't gone into. But I think that when you have changed the concept so much, it wouldn't be right to call it classical, you see. See, I think the main point, it's hard to say, the main point about would be rather whether we want to take the wave function as the whole description or not. See, I add this particle, right, and say the wave function has the meaning of information that acts on the particle. Right? Now,
maybe you should explain the wave function.
Yes, this wave function is a mathematical representation of the field of information, you see. In the case of one particle, it's like a wave, but it's a wave that acts according to its form and not according to its intensity. With many particles, it's more complex, you see.
And in the Bohr interpretation of atomic physics, you would say that the wave function is just something that we make up to describe.
We make it, well, it's something that Bohr called it an algorithm for calculating experimental results, right, in the phenomena. The wave function is part of an algorithm. You know what an algorithm is, you know?
A way of calculating.
A way of calculating, yeah.
And no more than that.
No more than that. Now, von Neumann said something a little bit different, that the wave function is a complete description of the quantum reality. Now, it's not clear whether Bohr would have ever talked of a quantum reality, because he only talked of this whole phenomenon, right?
But then in your interpretation, it's very important that the wave function is not just part of our description, but part of
we regard it as part of the reality. And see, this would be, if we make an analogy to society, one view would be to say society consists of a lot of people that you could see interrelated, but another view is to say they're interrelated by information exchange, right? Saying that's crucial. Without that, the society would collapse, right? Would not. So I say that's part of the reality of the society, right?
And could you elaborate on your view if you take it to societal analogies? How is your worldview if you give it as a description of human affairs in society?
Yes, well, see, if we think of society, you see, if you compare, you can have every individual trying to follow his own pool of information and leading to chaos. Or you can have people trying to move together with a common pool. And of course, you can have the attempt to impose a pool, but you see, I haven't, but that might lead to a conflict with the pools that are already there. See, I think it's essential to have coherence and order and harmony, that the whole society moves together with a common pool of information, like this ballet dance, which is not imposed, right? But which is established by exchange and dialogue, right?
Do you think we're moving in that direction?
Well, I think potentially we are. We need to, and some people may be, but you know the general trend hasn't got very far. You see, because everything is divided into nations and religions and other kinds of groups which behave as if they were independent. You see, and when they're not, so people will have to give all that up, and they may find it hard. You see, to deal with the ecological problem, I think people will have to give a great deal of that up.
So you're moving your emphasis from the persons, the individuals, the divided parts, to the information flow or the information field of society.
Yes, that's right. But I say each individual contains the whole information field of society in his own way. So,
how?
Well, it's in his mind, in his brain. You see, everything you know comes from society practically, right? It may be both information and misinformation, right? But it determines what you do, right?
But you have to read books to get the information.
Yes, but that comes from society, right? Books are part of society. They wouldn't exist. So I say that the individual is formed out of society, but together the individuals form society, right? Now, the individual needs to have freedom to look at all the information and determine, in his own way whether whether it's right or not. But finally, he has to be part of society. Now, or we'll call it the culture, if you like, then. So, the individual, see, now what we need for this is that we have so many different individuals, each with his own view, and different groups, each with their own view, coming into clash, right? Now, they have got to be able to talk about it, to dialogue, and to entertain each other's view, to look at it with calmly, so that each one can look at all the views, you see. And now, so each individual, if he holds all the views, then he holds the whole, right? Now, he doesn't necessarily agree with them, but out of that, I think, would emerge a common pool of information which would guide society.
And when you say that each individual in himself or herself has the whole human experience or knowledge.
Yes.
How does it get in there?
Well, in many ways. It gets in there, first of all, by osmosis. They pick it up implicitly from the family, from friends, from school, what you read, what you watch on television. Television is making this much more so, right? And also, there may be built in some instinctive information, which is common. And there may, for all we know, be hidden connections, which we don't know. But but implicitly, each person contains the whole, right? It's like a hologram which contains the whole, though not in all the detail. Right?
And the hologram is the way of making pictures in 3 dimensions.
In 3 dimensions, where you don't make a point-to-point correspondence between object and image, but where the waves, what you do is you take the waves from the whole into each region.
And so you can make an apple in 3 dimensions.
Yeah, well, not only that, but each part of the image contains an image of the whole, but with less detail than the whole. Right?
So you feel that the condition of each human individual is to be this fussy part of the hologram that contains the whole.
Yes, but at the same time, he is a contributor to the whole, right? You see, we have both views must be maintained.
But is this something that's created through history, or has it been there all the time?
Well, I think it's built into the way we are, you see, but, the groups were smaller in the past, that's all. You see, originally there were small groups of 20 to 40 hunter-gatherer, and then societies got larger. As they got larger, it became difficult to maintain a coherent whole, right? We had wars and many other conflicts, and we now have this challenge of 5 billion people. We have got to make it a coherent whole, or else we won't survive.
So it's an entirely new challenge.
Yes, I don't think it ever was before.
And your basic idea is that the architecture of human society is now such that there is an interaction between all the 5 million people at one time.
5 billion.
5 billion, sorry. But there's no actual understanding of coherence.
Actually, they are a whole, but it's incoherent, right? You see, they cannot avoid being a whole. They're exchanging. Every person is according to what the others are. You see, if two people are enemies, each one makes the other, right? Is that clear?
Each make the other an enemy.
Well, what he is, you see, two enemies are very closely related. You see, people who hate each other are extremely closely related, except that they're in an incoherent relationship, right? One that's very destructive, but people, and hate is a very close relationship, but destructive. Now it has to be turned to something else, right?
In this transition from seeing the world as parts to the world as a whole, that you think we all need to survive, there are going to be many difficulties. How do you see that transition?
Well, I don't see exactly how it's going to happen. You see, I think that we are faced with these challenges, you know, the danger of nuclear war, the danger of ecological destruction, or many other dangers, the fact that our cities are becoming difficult to live in. You see that the cars will eventually clog them up. Now, people are committed now to the view of growth, economic growth, but that is just what will destroy the planet, right? As if 5 billion people want to live at the present European, American standard of living, Japanese and so on, then they will be like a swarm of locusts descending on the planet. So somehow there has to be a change where we say the desire for material goods has to be more limited, which means people will have to find something else in life, right? If they want to survive, you see. So there won't even be material goods if we keep this up. And you see that you'll get, say, much more carbon dioxide, much more pollution, much more everything, you see. And so there is this challenge, and I see a beginning of a movement, you know, and especially due to the ecological challenge. Some movement has occurred on the nuclear challenge because of Gorbachev, which is encouraging. And so there is some movement in that way. The question is, will it be fast enough, you see? If we had more time, I would be much more confident.
But it seems that in the past 5 years there's been quite a change, for instance, on nuclear armaments.
Yes. I think primarily due to coming of Gorbachev, you see, that he has changed the whole atmosphere. If he can sustain that, that would be very good. If other people from the West can finally move with him.
So where you see the initiative these days is really in the East rather than in the West?
For the moment, yes. Well, there is some initiative in the West developing on the ecological question. You see, it's just very rudimentary, but you see, I don't think people have sunk in the magnitude of the change that's needed. You see, somebody has said that we spend $1 trillion a year throughout the world on armaments. That amount spent on the ecology would solve the problem. But if you spend a lot less than that, it probably won't. Otherwise, it will slow it down.
What's the most important thing, money or consciousness?
Consciousness. No, because whether money is spent will also depend on consciousness, you see, on whether we feel we're a part of this one world or whether we all think we're separate.
Now, Nils Bohr had this notion of an open world, and he was rather ridiculed when he published his open letter to the United Nations in 1950 about the necessity of human beings talking together over the bombs. How would you see that today?
Well, I think he saw the necessity at that time, but people weren't ready for it. Perhaps he was influenced by that feeling of wholeness too, which is in his view. And I think that people are more ready to listen to that now, but the crisis is developing at a very fast rate.
So in a sense what you're saying is that Bohr was seeing something, and nobody really understood him, maybe because he didn't dare to say it.
Well, I think they weren't ready to listen, you see. The people didn't want this one world. They were frightened of it. You know, they said, we have so many enemies, we want to take care of ourselves first, and so on. You see, those attitudes still prevail, but there's a movement away, right? Enough for people to listen.
Now, if we take the tradition that you are out of natural scientists that have been involved in discussing society, that is traditionally a tradition where spirituality and worldviews and religion are seen as enemies. If you take the left-wing natural scientist tradition from before the Second World War, how come that scientists today are interested in worldviews and spirituality?
Well, some are. I don't think a great many yet. Partly because the science itself has opened up that possibility in the way that I've described, and partly because I think, just as with other people, there's a growing sense of the inadequacy of the old approach. You see, that it will not only not solve all the problems that I've said, but also it creates a kind of empty life. You see, if you could imagine that we are successful, that the economy grew and grew and grew, what would we have at the end? You see, people would be bored, you see. In the 60s, when there was prosperity, you had all these hippies who they found it had no meaning. If we had that kind of prosperity, the kind of prosperity that people hoped for, I think the whole thing would collapse faster than ever.
But how are we going to become hippies? Through prosperity or through poverty?
Well, prosperity would make hippies. Poverty might make people who are afraid to lose their jobs, you see. But I think neither of those ways is going to work. You see, that a change of consciousness is needed. And the worldview is part of that.
And what is the most important way that this change in consciousness will come about, you think?
I don't know myself. I say many factors. It's like a stream from many springs, you see. But not only worldview, but I think one of the most important factors would be to have dialogue of many different kinds of people. Not only East and West or North and South, but say, for example, a dialogue among scientists. I think scientists find it very hard to have a true dialogue because they're so committed to their views. They should have dialogues among each other or with non-scientists, you see, or even religious.
And now in 20 minutes you're going to have a dialogue with the scientists here at the Nils Bohr Institute. It's been some decades since your ideas have been presented here, hasn't it?
Yes. Well, I came here in 1957 for 1 month in the summer, and then again in 58. Now, at that time, I was just moving from Israel to England, and we spent a month here at the Institute. And we talked about physics mostly at that time.
Do you find that the kind of ideas that you present are easily understood in an environment like the Bohr Institute?
Well, I haven't tried the Bohr Institute yet. I just came, but I think that scientists find it harder in some ways than many other people, you see, and some other people, because there's still a strong commitment, even perhaps partly unconscious, to the old atomistic worldview.
So what you're saying is that science has shown us something that scientists do not want to see.
Well, they have become so used to the way of seeing it that they don't want to change it. You see, they feel uncomfortable about changing it, and they feel there's no reason to change it. Many of them, they say, well, we're doing so well now, why should we change it? In one sense, it looks as if we're doing very well, you see, but if you look at the broader view, it looks very dangerous.
Thank you.